the way that we define radians has a few nice properties. It results in some really nice things that happen when we're dealing with circles in particular. I want us to think about, again, the unit circle. So this is the circle with a radius of 1. I'm controlling the radius using this slider over here. I can make it bigger or smaller. Okay. But we can see here that I've defined an arc on the circle. And you can see that however long that arc is, so at the moment it's 1.28 units, that's the same as the angle at the center. And that's the way that we've defined radians. That's the way that we're working with them. So if I make it so that that arc distance is a particular value, about 4 here, okay, then I've got 4 radians in the middle of the circle. Now, unfortunately, I can't get this thing to show in terms of pi. It's just rounding to the nearest decimal, but you get the idea. This is the way that radians are defined with the unit circle. What happens if I change the size of my circle, though? What if I'm not dealing with the unit circle? So let's have a look. I'm going to make this radius 2. So I've made my circle twice as big. Just zoom out a little bit. Now we can see here now that the angle at the center and the arc distance are not the same thing anymore. In fact, if I move this around, have a look at some of the values that we're going to get. Okay, you can probably work out, if I make this a nice number, the arc length now is twice as big as the angle at the center when I've got a radius of 2. Okay, if I make this 4, I've got an arc length of 8 around the outside. Let's try making it half the size. What if we had an angle of a radius of a half? Well, in this case, the arc length is half the size of the angle at the center. So there's this really nice property, a nice easy relationship between the angle at the center, measured in radians, and the arc length in a circle. And this is what the relationship is. Okay. If we know this angle at the center, theta, and we want to find out the arc length, which we'll call L, that's just a curly L there, then we can work out what L is by taking the radius of the circle, so this distance here, and multiplying it by the angle measured in radians. So this is what's called the arc length formula. It's a very useful result. And it says that the arc length L is equal to the radius times theta measured in radians.